Hello everyone. So, today we will design and we will study common emitter configuration, which one is the most efficient one to design a transistor circuit. In case of the last combination, that is common base configuration, we have seen that the output current IC is almost equal to the input current IE. Now, in this case we have to see the output is how much amplified. So, now in case of common emitter, as I told you, common emitter means emitter, suppose this one is NPN transistor. In case of this transistor, this emitter part will be common in case of input and as well as for the output. So, we have to consider input part like this way and we have to consider output from this part or from this port. So, we have designed by the circuit symbol as well as the PNP transistor also. So, in case of this NPN transistor, so in case of this NPN transistor, so first PN junction diode is in forward bias condition and the next PN junction diode is in reverse bias condition. As I told you, in case of transistor action, first the PN junction diode will be considered in forward bias condition and the next PN junction diode will be considered in reverse bias condition. So, this is all about common emitter configuration. Now, we have to see in case of input, we know that in case of common emitter, at input side and output side emitter part will be common. So, when we calculate the input, we have to calculate the input current, that is IB versus VBE, and whenever we will calculate the output voltage or output current, then we have to calculate the output current IC versus the output voltage VCE. Now, in case of input voltage, we can see or we can conclude that whenever this PN junction diode, that means only the first PN junction diode in case of the input circuit, when this PN junction diode is in forward bias, then the input current IB, the output waveform for IB will be normal diode current, that is IB, and obviously that is measured in microampere range. So, whenever this PN junction diode is connected in forward bias condition, the output waveform of IB will look like normal PN junction output of normal PN junction diode output. So, this one is say conditioned is that VCE, that is this one common emitter is say right now is suppose it is in 0 volt. So, we have biased the second PN junction diode by 0 volt. So, if we consider the second PN junction diode is in 0 volt or unbiased condition, then the waveform will look like this. Now, if we change or if we increase the common emitter voltage from 0 to say 4, 5 like this way, then what will be the effect on IB current or input base current? Will it increase or will it decrease? The answer is the IB current will decrease. Now, the question is why? If we increase the VCE common emitter current, then why the base current will decrease? Now, see, if we increase this PN the diode voltage or reverse bias voltage across this PN junction diode, then what will happen? If we increase this VCE voltage, then there will be more depletion layer across this PN junction diode, and for that reason what will happen, the thickness of the base will be very small. So, if we increase the more reverse bias voltage, that will decrease the thickness or width of the base region, and if the base region decreases, then obviously the base current will decrease more, and for that reason when we increase the base collector emitter voltage, then the IB current will decrease. So, here VCE, sorry, this one is not less than. So, when we increase the common emitter voltage, then for that purpose the IB current or base current will decrease. So, this is all about input.